well this video is for Math 116, and we're going to talk about maximum and minimum values. So this section of the textbook is actually pretty short, and we won't get too deep into this discussion of maximum and minimum values in this section. We'll do a lot more with it at the end of chapter 1, and that's where we'll see these calculus word problems that we'll talk about for maximum and minimum values. So essentially, the key to this idea or this concept is the idea of writing a formula to represent a physical situation. Okay, that's what we won't get into until the end of chapter 1. But you know, in the sciences and in a lot of other applications as well, you know, that's the challenge, is to write an equation or a formula that represents a physical situation or something that's happening in the world around us, and then to look at the graph so that you get a visual representation of what's happening. Okay? And these things are never perfect representations. They're always flawed. They are not reality. If you've ever heard the phrase, don't mistake the map for the territory, that's sort of what I'm talking about. If you've never heard that phrase, what it means is don't mistake the representation for the reality. Okay? They're always different, but the representation can be very helpful. So if you've got a formula, you can make a graph, and that representation can help you to think about what it's representing, the reality that it represents. And in that sense, you can find these maximum values. You know, in business, they'll come up with formulas that represent profit. And if you want to maximize the profit, then this is the X value you should be looking for. Okay? Conversely, in a business, if you're looking to minimize cost, right, then you can find the minimum value of the curve and the X value that goes along with that. And again, we'll see this a lot more at the end of chapter 1. So this section, 1.3, is just a brief introduction to the concept of maximum and minimum values, and also some follow-up on domain and range. So let me get a drink of water, and then we'll look at problem number 2. Okay, so I'll do a little sketch for problem number 2 here. And some of these will be estimates in terms of the values of x and y that we're going to be looking at here. So let's see here. We've got a point here at 1, 4. And then the graph looks like an upside down parabola that ends down here where x is 8. And y, it looks pretty clear that y is -3 there. Okay? All right, so let's see. So we want to find the domain and range. So domain, let's see, our x values go from 1 to 8. So inclusive, so we can do this or we can do this. On the quiz, I don't know if you noticed, I can't give you a choice between these. I have to force everybody to do one or the other. And so I think this one's simpler to understand. I think more people understand how to use inequalities. And so that's the one that I chose. Okay? When it comes to paper tests, you can do either one. Okay? All right, so now we need the range. What are the y values? So here's the bottom y value down at -3. And then the top y value, I know sometimes people look at the end point for the y value, but the top y value is up here, and what is that? We'll call it 13. Okay, it looks like it's pretty clearly between 12 and 14, and so we'll call it 13. And again, if you want to use interval notation, it'll look like that. All right, maximum and minimum values. So here, the maximum y value is 13. And that happens, oh, do we have an x value for that? Where is that happening? I think we can call that 4. So some of this is an estimation. when we get into things that have actual formulas, we'll be able to be more exact with these answers. With some of these where we're just pulling this off a graph, there is some estimation that comes into this, and I try to be understanding when I'm grading in that sense. Okay, the minimum y value is down here, y equals -3, and that happens where x equals 8. Okay, so there's problem 2, and again, we'll look at those word problems at the end of chapter 1, and then also if you end up taking a calculus course, you will get, typically in most calculus courses, you dig much more deeply into this kind of curve analysis. You do look at maximum and minimum values, and then you look at a lot of other things as well. Okay, so let's look at problem 4. Do a little sketch for problem 4 here. And let's see what we've got. Move this out of the way a little bit. And let's see, so we start up here, comes down like that, and that's the point 416. And this point over here, what is that? We'll call it -1 and 11. It's just below the 12 there. Okay. So first, we'll talk about domain and range. Domain are the x values, and those go from -1 up to +4. And again, we can use that interval notation if we want to. The range are the y values, and again, don't get thrown off by the endpoints here. The y value is down here at 0, and then where is that top y value there? We'll call it 27. Okay, so 0 up to 27, and then we can do it in interval notation like that if we want to. Okay, so the maximum value here is y equals 27, and we'll say that that happens at x equals 3. And the minimum value here is y equals 0. And that looks like it's happening where x is equal to 0. Okay, so that's it for section 1.3. Like I said, it's a pretty short section. The next section, 1.4, is going to be quite a bit longer. We'll push that back into week 2, so this will be the end of the week 1 assignments. And then we'll come back and start in with section 1.4. As always, if you have any questions, please let me know. Thanks.